I've been using Mockito for many, many years, but mostly what caused me to really want to get into like writing about Mockito was that I kept teaching these training classes and I get people coming in who didn't really understand what Mockito was for. Why do I even want to do this? Not only that, there's an undercurrent in the industry. There's a certain small but very vocal group of people that just object to mocking frameworks at all. They just think, no, that's a mistake. Everything should be an integration test or a full functional test and all of that. What I want to talk to you about is why you would use Mockito and why you wouldn't. I mean, really, when is it that this is a useful thing? When does it solve some problems? And when should you not bother? You know, I agree. It's one of those things that if you have a use case that it fits, it's really helpful. And if you don't, then don't worry about it. You know, so I'm going to focus on that. Now, we're going to talk about mocks and stubs and spies, and this is another source of confusion in the industry, is actually defining those terms, because you get a lot of different definitions in different places, and I'll tell you what I believe they mean. Another problem is that if you look at the Mockito website and look at the documentation there, it's very, very good at explaining how to get Mockito to do what you want, but it's not very good at explaining why you would want it in the first place, what you want to do with it. So again, that's what I'm focusing on. So my name is Ken Kousen. There's that. There's all my contact information, email address, homepage, blog, Twitter handle, Mastodon link. And I have a free weekly newsletter that comes out every Sunday. Called Tales from the Jar Side. That's on Substack, and I have a companion YouTube channel as well. I've got a whole Mockito playlist on the YouTube channel. In fact, as among those books there, this is the one that I'm focusing on. I wrote a book called Mockito Made Clear that came out about a year ago, a little bit over a year ago. But one of the things that's interesting about Mockito is that even though the version keeps changing, the underlying code, the API, has remained remarkably stable over many, many versions. So if you're on Mockito version 2, 3, 4, or 5, it's probably all the same stuff. You know, it really is. I'll talk about that. So at any rate, the one thing I did want to tell you, though, two things on this. First of all, this GitHub link has got the one with all the code in it that I'm going to be showing you today, the one I'm going to be spending my time on. So it's in my GitHub repository under my last name, KOUSEN/Mockito book, you know, because I didn't have a name for the book when I came up with the repository. So there's that. And the other thing is that if you decide you're at all interested in the book, let me give you a discount code. You'd have to get it from Pragmatic Programmers, from pragprog.com. This wouldn't work at Amazon, but it would work at pragprog.com as an ebook. And just use KK, my initials, Mockito, all lowercase, one word, 35. And that'll give you a 35% discount on the book. If you want to try KK Mockito 85 and see if that works, let me know. But if you really think it through, you try KK Mockito 105 and see if they'll pay you to take it away. You know, so. Okay, so I want to talk to you about a particular problem that I want to use as a bit of an illustration of when this sort of mocking framework would come up in the first place. Now, I mentioned this before, but if I go to open-notify.org, then this is a site, and if the well, this seemed to be coming. If the internet access is at all flaky, I have all this in the slides anyway, so I'll give it a try here. But if it turns out to be slow, you know, that's all right. So these are a set of open APIs based on data consumed from NASA. I don't know how often the developer updates it, probably daily, something like that. But there's a service here called Number of People in Space. It's trying to find out how many astronauts are currently in orbit at any given moment. And you see that it's a RESTful web service. If I magnify that, I think it's about as big as I can go. api.open-notify.org/astros.json. And when you get back, it's a JSON object that has a message which says success, hopefully. And then a number is the number of people in space. And then people is a collection of name and craft combinations. So I need a a Java record or class to represent the name and craft combinations. I need one for the whole thing itself. But what I like about the service is it's free. It doesn't collect any data. It doesn't throttle anything. I mean, it only supports GET requests, but so be it. And I can consume this at any time. Okay? So what I'm going to do, and again, there's a sample of what some of the data looked like when I happened to make the slide a while ago. And you see people's a collection of name craft combinations, and then there's a message at the bottom along with the number. So what I actually want isn't that. I mean, it's easy enough to make a REST call and get that data back. I want to process that data and find out if there are multiple vehicles in space, how many astronauts are aboard each one. Now, if you were in the last talk in this room, you could do it all with SQL, but okay, it's JSON data on a RESTful web service. I'll do it in Java. So I can call the RESTful web service to get the JSON data. I can parse that into records, and then I can do basically a group by operation, grouping the astronauts by spacecraft, and I'll wind up with a map where the keys are the spacecraft names and the values are the number of astronauts per element. So it'll look something like this. This was about a year ago. There were 7 astronauts on the International Space Station and 3 aboard what at the time was called the Shenzhou 13, whatever the Chinese space station was called. Then they changed the name of the space station, and now I don't think there's anybody aboard it. But at least according to the NASA data, I don't get anything from it. So I don't know what happened. Maybe they're planning to send people up later. Maybe it's blocked in India. I didn't even think of that. Yeah. Like TikTok, apparently, like we're trying to do. I don't know. All right, so the way I'm going to solve this problem is I'll start with an interface called gateway, because a gateway is a design pattern that's designed to wrap network access. If I'm going to do access a network and bring back data, a gateway is a very common term for that. So I'm going to use a method called getResponse that will return some generic type based on that. Now I'm going to implement that in a class called an Astro gateway, which is going to implement getResponse to return an Astro response. That's the object I'm going to make, and that's the class that's going to map to all that JSON data. So you can see at the top I've got the URL sitting there, or the default URL, which is the one I'm going to use. And then in getResponse, I have to do some sort of networking to get there, and then I have to parse all that data. And it either works or it doesn't work. I either get it and I'm able to parse it, or it fails. So I'm saying here, let's say I'm using the retrofit library, or I could use the Java HTTP client library, or I could use Spring, whatever. There's tons of open source HTTP libraries that I could use Apache HTTP components or something. Well, if it works, in the try block, I'll say, well, let's go get it and navigate down to the objects. Great, I'll return that. If it fails with an IO exception or some kind of networking exception, I'll wrap that in a runtime exception and rethrow it. So that's all I'm going to do. So the idea is that an Astro service is going to sit on top of this. That was just the gateway. The service is then going to post-process the Astro results and convert it into what I want. So here you can see the Astro service has an attribute that is of type gateway in it, specifically a gateway of type Astro response. And I'm doing effectively by hand the Spring auto wiring. I'm just plugging it into the constructor. Okay, so I've got a constructor that takes the gateway. And then when I call my getAstroData, I get a response and I have some method to do my group by operation in terms of streams and whatever I need to, the filters or whatever I need to do the group by. Okay, now when I write a test, I would either call this an integration test or a full functional test, depending on how you want to define it. Then I'll use the real gateway, I'll use the real service, I'll go ahead and call it, and then I have to have something to compare the results to. Now, of course, I don't know how many astronauts in space are at the moment. I don't know what the data says. So I can't hard code a test case to say this many astronauts, here are their names and everything. I can do some stuff. I could say, well, the number of astronauts has got to be greater than or equal to 0, or something seriously went wrong. If you have a negative number of astronauts, that I don't even want to think about that. Also, I can do silly stuff like saying, well, the names of the crafts can't be empty or blank. I mean, most people actually put a name on their craft, so it wouldn't be good that way. But if everything works, we'd be happy. But what if something goes wrong? Now, first of all, I do have a little bit of a snippet of a test case here, and you can see I get the Astro data. So the first line 5 there is showing I instantiate the service with the gateway as the argument. So this is a full integration test, if you will. And then I call the get Astro data and I get my map back, and then I'm using the assert all method from JUnit 5. So I say for each combination of craft and number, this is how you can iterate over a map now with a by consumer, then I'll print out the number of astronauts aboard, whatever the craft is, and I'll check that. That's assert J, by the way. Assert that number is greater than 0, or actually nowadays I use the dot is positive method, same deal. And then assert that the craft name is not blank. Now, if that works, I'm happy. See, one of the things that seems to confuse people in the community, when you get people saying you shouldn't be doing mocks, you should do a full test because mocks won't tell you that it's working. Here's the thing. Nobody who works with Mockito ever says, oh, don't do a full functional test. Nobody says don't do that. Mockito's not designed to replace that. Let's look at this from a different point of view. If you get in a car and you drive to your destination and you get there, that's a full functional test of the car. Everything worked. It succeeded. You're fine. But if something goes wrong in the car and you wind up on the side of the road, then what's the mechanic going to do? They're going to have to isolate the problem. Was it the transmission? Was it the steering? Was it a starter? Were you just out of gas? You know, it could be anything. And they need to separate it into modules and isolate the individual section so they can find out where the problem is. Same thing. You do a full integration test on your system and the system works, you win. You're good. Everything's fine. You don't need mocks anymore. But if something goes wrong, the purpose of the mocks is to allow you to isolate each system independently so you can find out where the problem is. The problem, if you will, is that the way we think of testing, which is perfectly reasonable, by the way, is we go bottom up instead of top down. I'm going to do a unit test on each individual class, and then I'll do an integration test, and maybe someday I'll get around to doing a full functional test. Just try to picture it in the other order. No, if I put it in production, that's a full functional test, whether I wrote it that way or not, right? But if it doesn't work, now I need to isolate it, and I may need to isolate it all the way down to unit tests, individual units. Now, there's another problem in the industry I want to mention, and the problem is when the term unit test was created, way back when Martin Fowler was writing about this stuff and everything, he didn't mean unit equals class. That's what it turned out to eventually evolve into. At the time, unit was unit of work. It was a use case, basically. What we would now call an integration test is what they meant originally as a unit test. So when you hear people saying, oh, I've got all these unit tests, and they're all thinking class by class by class, but that's not very useful because every class depends on something, right? No class is an island entire unto itself and all that. You know, you do have to do integration tests anyway. So don't think of unit as a single class. Think of it as a grouping. And again, we're going to try to isolate it. Now, in this problem, what could go wrong with finding out the number of astronauts on each craft? Well, maybe the network's down. You know, I mean, that way I couldn't get to there. Or maybe I have a networking library, but I've never used retrofit before and I did it wrong. That could happen. Or maybe I grabbed the JSON data and I didn't parse it correctly. I mean, not me, but somebody else. You know, no, I mean, it could easily happen all the time. You parse the data wrong. Or maybe I got the data and I got everything back and then I did that group by operation and implemented it incorrectly. Lots of things could go wrong. Now the goal is to isolate the problem. Now, let's start talking about mocks and stubs, because that's another source of confusion, is what's a mock, what's a stub, what's the difference? By the way, for my definition that I'm going to follow, I'm following a very famous blog post put up by Martin Fowler himself, you know, the chief scientist at ThoughtWorks, and wrote Patterns of Enterprise Application Architecture along with dozens of other books. Big, big name. He wrote a post years ago called Mocks Aren't Stubs. And if you just Google that, you'll find it. I mean, it's a very famous post, although again, it's kind of dated at this point, but I'm using his definitions. I want to test my service and my gateway separately so that I can narrow down where the problem is. Now, the gateway's an issue, but the service depends on the gateway. The gateway, what is it dependent on? Well, the gateway uses that networking library, whatever I was implementing it with, and the gateway uses some kind of JSON parser, parse the JSON data in there. I'll do a test on the gateway, but what about the underlying libraries there, the JSON library and the networking library? Well, let's come back to that problem and just start off by saying, let me just use the libraries as they are, and I'll do a real full functional integration test, whatever you want to call it, on that. So this is a test that says, okay, I'm just going to instantiate the Astro gateway, and then I will call get response, and I'll print out everything on the people, and I'll go in and check the number and say that the size of the people collection should match the number. In this case, I actually use POJOs rather than records. That's why these are all getters inside there. At the time I was writing the book, everybody said, because I wanted to write in Java 17, and they said, you really want to force everybody to be up to 17 when you wrote this? And I'm like, yeah, but no, I backed off to 11. But at any rate, so it's just using a POJO. And again, if this passes, we're good. I mean, the gateway's fine, because the gateway's only dependencies are libraries. And do you want to mock a library? Let me just spoiler alert, don't mock a library. In fact, even the Mockito team says, do not mock classes you do not own. Only mock things you own. And when I come back to it later, I'll talk about why you never want to do that. So this is technically, by the definition these days, an integration test, because I'm using the real network, I'm using the real libraries, I'm not testing a class in isolation. But if you go back to the whole unit of work idea, I would call this a unit test, but okay, it's just a semantic, you know, how you want to define it. Now, on the other hand, the Astro service depends on the gateway, and that I can isolate. Now, there's a couple ways to do it, and this is what you get people saying. Why should I use a mocking tool like Mockito? I'll write my own mock or stub, but we'll come back to that. I mean, you'll write it yourself. But whether you write it yourself or you let Mockito auto-generate it, either way, you're putting in what they call a fake object. This is just a stand-in. It's a rigged demo. When I call this method on this object, here's the answer I want back. I don't care what the real answer is. I just want this one fixed so that if I have an error in the service, it's not dependent on the gateway. The gateway's fine. It's not relevant here. So here, what the heck, I wrote my own mock object. It says a new Astro response. I instantiated it, and I plugged in data, and I had some fun with it. I put various people in space on various science fiction ships. I got a couple on Voyager, one on the Jupiter too, if you're, really want to roll your eyes and say, okay, boomer, The Rocinante, you get that one at all? Anybody watch The Expanse at all on Amazon Prime? Yeah, that's a really good science fiction show. The Nostromo, Ellen Ripley, you got to get that one, right? That's the Alien movie set down on LV 429. You don't want to go there. Spoiler alert, by the way, the actor who played Will Robinson on Lost in Space back in the 60s is the same actor who played Lanier on Babylon 5 in the 90s. Billy Mooney, believe it or not. So there's an Easter egg for you for the book. So, okay, but I wrote it myself. Okay, put the whole thing together. Now, when I say, oh, I need a gateway, I'll just plug in my mock gateway. And in fact, that's what this does. It instantiates the Astro service with the mock gateway in it and get the data back and check the numbers. Okay, fine, well and good. Didn't need Mockito for any of that. But I only had one method. Get response. That was the only thing I needed. If the object I'm mocking had 10 methods in it, I'd have to implement them all, even if I only used one, right? Say it was an interface, I have to plug them all in. Also, I have to rewrite the mock every time the situation changes. And if you wrote it, you got to maintain it. So that's a problem. Also, I can write the mock there, but that was the success case. What if I'm trying to simulate failures? What if I wanted to throw an exception if the network's down, or throw an exception if the parsing fails or something like that? Now I need 3 mocks. I have to write them all myself, and I have to maintain them if the API changes at all. And then this one is much more subtle. If I plug in my own mock, what I can't do is check that the service called the right methods on the mock the right number of times in the right order. Java has no built-in way to do that. To say, oh, this method was called X number of times, and then this method, and then that method. I mean, you could keep a counter yourself. You could write it yourself, but it's not built in at all. Okay? However, either way, whether I make it myself or whether I use Mockito, I have to create a mock object for each use case. I do what's called set the expectations on the mock. When I call this method with these arguments, here's the answer I want back. I have to specify, this is exactly what I want back under this circumstance. It's called setting the expectations. Then I have to somehow plug it into the class I'm testing. Remember, I'm not testing the gateway. I'm testing the service. Okay? But I have to have a way to get my mock gateway into the service. Now, I set it up with this in mind. I provided a constructor. That's an easy way to plug it in. This is like when that mechanic's looking at your car. Hopefully it's nice and modular, and they can isolate the conditions that way, and they don't have to worry about all the interlocking pieces like that. So I inject the mock into the class I'm testing. Then I run the test and see if the service is doing what I'm supposed to do. And then finally, there's that part at the end where you so-called verify the interactions, meaning did my class I'm testing call the right methods in the mock at the right time, in the right order, with the right arguments, that sort of thing. That's verifying the mock. Here's an example. So this, again, is using the one, doesn't use Mockito. Actually, this one does use Mockito. So I'm moving my way into the actual Mockito part. You see on the right-hand side, I've got this mock gateway. I suppose I could use this, couldn't I? Yeah, I don't know if that helps you any. But there's the mock method. See that? That's a static method in the Mockito class to create a mock object of type gateway. And I just put in the interface. Here I set the expectations. Another static method, when. When I call getResponse on the mock gateway, then return some mock astro response that I prepared ahead of time. When I call this method, I want this result back. Then I inject the mock into the class I'm actually testing, the astro service. In this case, I have a constructor to do it. Run the test. Remember, I'm testing the service. I check the results with all the assorted checks. And then finally, optionally, I can verify that on the mock gateway, the getResponse method was invoked exactly once. Because once is the default. So I know what was going on there. See all the steps laid out? And whether I do it manually or do it with Mockito, the same steps have to happen. Now, was that a mock or was it a stub? And what's the difference? And which one do you use? Here's the way to think about it. A stub is a fake object that stands in for the real one, and it provides specific results for certain method calls. When I call this method with these arguments, here's what I want back. That's a stub. You set expectations on a stub. Don't test stubs. Trust that you can write a stub. You know, that you're telling it, when I call this, I want that back. The reason I have to say don't test it is because if you look at the Mockito documentation, it's full of tests of stubs. Why? Because they're trying to teach you how to set expectations using Mockito. So they're showing you the API. This is how you make it do that, and here's a test to prove we did it right. In your code, remember, you're not testing the stub. You're testing a class that depends on the stub. Okay? See if this is working too. Yeah. A mock is the same thing. It stands in for the dependency. But the difference is you verify a mock. You check that the methods in the mock were called the right number of times in the right order with the right arguments. If you called verify, it's a mock. If you didn't call verify, it's a stub. But the thing is, the class, now it went to. The created class, the object you made, is the same either way. That's why it's so easy to use the terms interchangeably, right? I mean, you either wrote the class yourself or you had Mockito write it, but it's the same class. The only difference is how you use it. With the stub, you're setting the expectations. With a mock, you're setting the expectations and you verify the interaction, or what they often call the protocol. That's the interaction between the class you're testing and its dependencies. Okay? So if you did call verify, it's a mock. If you didn't, it's a stub. So that's why you noticed we used a mock method. There is no stub method in Mockito. You just call the mock method and you don't verify. They had a stub method in the early days and they got rid of it because it's the same class. The implementation of the stub method would be identical to the implementation of mock. Now, since we're talking about that, let me take a quick diversion to say, what the heck's a spy then? Because spies come up too, and Mockito generates spies for you. Now, this is not quite the way I want to say it, so I'll start with this. Yeah, a spy can be a partial mock. It's a mock where you override some of the methods and not all of them. That's dangerous. They tell you try to avoid doing that because you can put the object in an inconsistent state. Like, let's say you do something you should never do, which is to mock a list. I mean, the Mockito documentation is full of examples of mocking a list. And the first example they use, the first one in the documentation, they preface it by saying, yeah, don't do this. Use a real list. So then you go, well, why are you doing it in the documentation? Well, because everybody knows how a list works. We're all familiar with an add method and a clear method and a remove method. We know how it works, so we'll use that as our demo, but don't do this. Well, a spy wraps around an existing object. And it allows you to mock some of the methods if you want, or set expectations on some of the methods. But more importantly, it allows you to check the protocol. If I have a class that uses a list as a dependency, then I can wrap a spy around it and check that the spy methods were called the right number of times in the right order. Now, let me not use a list because everybody does, again, you're not supposed to use a list. Where have I used a spy? One time somebody said they had to test logging. They were using a logging framework to write out logs. And they thought the only way they could test logging was to capture the log output. Capture the console, capture the file it was going into, parse all the log statements and everything. I went, no. You don't want to be writing a test for the logger. The people who wrote the logging framework wrote tests for the logger. They know how it happens. What you want to know is, did the info method get called? Did the debug method get called the right number of times, maybe when you expect it in the right order? That's where you use a spy. You wrap a spy around the logger. You plug the spy in, and you can verify the spy. You don't have to mock any of it. You don't have to stub out any of the methods. See what I mean? Because I don't care how the info method works. That's not my problem. That's the person who wrote the logging framework. I just want to verify that it got called with the right argument. That I can do. That's a perfect use case for a spy. See? Okay, now moving back. Oh, and again, I'll just warn you, what you can do with spies, however, is you can do a partial mock, and that's dangerous. Like, say I was mocking a list, and I said, when I call the add method, just return true, because add and list returns a Boolean. But if I call the size method, return 3. Okay? Which you can do with a mock. But now, what if I call add 4 times? Now the object's in an inconsistent state. I mean, I say when I call size, it says 3, but it's really 4. Remember, with a spy, there's a real underlying object. Now, you can do it, but you got to know what you're doing, and you have to only use it when you need it. Times I've seen a spy used as a partial mock is if, say, you had one part of your system that required a user to log in first, and somehow you need to get past that security portion. So you override the is the user logged in method to say, yeah, they're logged in. Now we go on. You know what I mean? That might be a case. But again, be careful with that. Okay, so say you want to do this. How do you do it? Well, you need to replace any of your dependencies on the class you're testing with mocks and stubs. So here's another complication with Mockito. This is a symptom of an old project that's never really been cleaned up. There are two parallel, essentially identical APIs in Mockito. And they both are in active use. I mean, you can't get rid of one or can't get rid of the other, but you'll encounter both in practice. One was based on that when method that I started my mock with. When I do this method, then return the following. Do we have to go out there and yell at them and say, hey, we're trying to learn something here? No? Like they would listen. Like I would go out there. I'll say that, but I'm a coward. I would never do that. But I could encourage you to do it. No, I shouldn't. The people here are too nice to me. Oh my goodness. Yeah. I should do my example of how nice Indians are to me. I need a victim. Who's willing to answer a question for me? Okay, well, I'll just use you if you don't mind, okay? Okay, Bangalore, that's easy to say for an American. Chennai, no problem. I'm going to say Hyderabad. Does that sound right to you? Hyderabad? Now say it back to me. See, it's different. Every Indian I know, they go, yeah, that's good. And then they say it back and it's different. They're all just being nice to me. Happens every time, you know. I'm never going to get it right. But anyway, one API starts with a when method. And then you have several then methods. Then return, then throw, if you want to throw an exception, then answer, which is a kind of a cool one, okay? Lots of options there. Alternatively, after Mockito was already established in the industry, behavior-driven development became a thing. People are like, ooh, we should be doing, you know, when this, then that, you know, write it out, given the following, when I call this change, then here are the results. But of course, they'd already used when. You know, they messed it up. So they made another class called BDD Mockito, which is actually a subclass of Mockito. You want to talk about a lousy use of inheritance. But they did it. And that one has a static method called given. And instead of then return, they have will return or will throw or will answer. And you'll see them both. Now, there's a couple other differences too, but you're going to see both in actual practice. And which one you use is purely dependent on how much the developer who wrote it cares about BDD. You know, if they're a real giant fan of BDD, they're using the given and when stuff, given and will. But if they're just seeing lots of code, they use when. Okay, now, Mockito is located at mockito.org. There's a set of Java docs there. And this is one of the weird APIs because I have to show you, here's the Mockito site. And it says, the documentation, let me magnify that. The documentation for all versions is hosted at javadoc.io. Of all places. So let me open that in a separate tab. And the reason I'm opening this is because you can see the version at the top, and this is Mockito core and everything. What little documentation Mockito has is buried inside the Mockito class. This is the Mockito class. See how they got this contents and a whole bunch of, you know, items that go up to like 54. And they're in no coherent order. Some of them are related, some of them are not. They're all kind of random. That's what we have for documentation. And like I said, if I go down to just the first one where they do a mock, let's verify some behavior. They start right off by saying, the following examples mock a list. And then they say, yeah, don't do that. But that's where the documentation lives. Now, the good news is there's also a wiki page. And the wiki page, if I go to GitHub here, so I go to GitHub on this, and on the GitHub repository, you can look at the code if you want, but there's a wiki link also, and on the wiki link, there's a whole series of pages here, including like a frequently asked question one, or how to write good tests, a series of options there. That's not bad. But a lot of people don't even realize that's there, okay? So I listed those. I put a link to the FAQ. I put a link. There's a mailing list, but I don't get it, because that is the lowest volume mailing list I've ever been on in my life. There'll be like one question every couple of months, and then you hope somebody answers it. So clearly the core team is not hanging out there. I don't know where they are. I managed to contact one to write a preface to the book or forward, but I don't know where they're hanging out. I think they got tired of that undercurrent of people who just don't like mocks and will complain about them endlessly, but I don't know. Any rate, here's another thing you should be aware of on version numbers. Mockito 2 really was different from Mockito 1. They really did change it. And if you go Googling for Mockito examples, be careful you don't get a Mockito 1. They're still out there, and nobody uses that anymore. The difference between Mockito 2 and Mockito 3, major version change, is they required Java 8. That was it. That was the difference. Same code, same API, but inside now they require Java 8. Okay? The only difference between Mockito 3 and Mockito 4 is a bunch of methods and classes that were deprecated in 3 were removed in 4. That's it. That's the only difference. So if you weren't using anything deprecated, you're fine. Between 4 and 5, there were actually 2 differences. One is that they moved up the minimum JDK to Java 11 at that point. Again, not much of a challenge for the people in this room. That's fine. But also, mocking something that's final or mocking something that's static started off as things the Mockito team said, yeah, we're not going to do that, and eventually went, yeah, okay, and they did it. In order to do either of those things, you needed this thing called an inline mock maker, which is just another dependency in your build file. You had to add that dependency. In Mockito 5, they wrapped that into core. So now you don't need to add the dependency. That's the difference in Mockito 5. See what I mean? I have never seen a project change major versions 4 times and change essentially nothing. Okay, if you have Mockito 2 code, you could change your dependency to Mockito 5.11.0 and it'll probably work exactly the same way with no complaints and no problems whatsoever. I mean, I can't believe it, but there it is. Okay, the dependency you used to put, well, actually I do put in 2 dependencies. One is the Mockito core dependency, the other is the JUnit extension for JUnit 5. Because that's going to allow me to use some annotations. The code I showed you didn't use any annotations. It was all, when and then and all that stuff. So, and by the way, there's the parallel Maven dependency, although I didn't put in the JUnit part too, but that would be in there as well. Now, I do want to talk about the annotation support. I used the mock method in the example I showed. If you use the Mockito JUnit 5 extension, extends with Mockito.class or whatever they call it, then you could use 2 annotations, one called @mock and one called @injectMocks. @mock tells Mockito, hey, create a mock object for me out of this. Now, remember, you annotate things that are attributes, so you have to have your dependencies as attributes to do this in your test class. Okay, make a mock of this and this and this, and @injectMocks goes on the attribute representing the class you're testing, CUT, class under test. Okay, so you put injectMocks there, and then Mockito will try very hard to plug the mocks into the class you're testing. Now, again, they hedge their bets. They say, well, look, Mockito's not a true dependency injection framework, but if there's a big constructor and the constructor takes all the dependencies as arguments, yeah, we'll plug it in. If there's no constructor, but there are setter methods to plug in the dependencies and they look like we're expecting, yeah, we'll plug them in. If there aren't setter methods, but there are private attributes and you can let us use reflection, we'll take a shot at it. We'll try to plug those in. But if anything goes wrong, we quit. We'll give up. Now remember the process, you create the mock object, you set the expectations, you inject it into your class under test. This skips 2 steps. You don't have to create the mock object, you can just set the expectations right away. You don't have to inject it into the class under test, Mockito will do it for you. By the way, you know what is a dependency injection framework? Spring. Spring includes Mockito as a dependency anytime you use the testing framework in Spring, which is always. right? It includes JUnit, it includes Mockito, it includes assert J. There's a handful of other testing libraries. Very good. But Spring adds another annotation that I don't have in the slides. I'm just going to tell you. It's called mockbean. You heard of this one? Some people have, yeah. What mockbean does is it solves the injection problem. It replaces any instance of the class in the application context with your mock, so that your mock is now available for dependency injection. See, if you're not using Spring, you provide a constructor, setter, or what have you. If you are using Spring, you may be relying on dependency injection. You never actually say anything other than add auto-wired, you know? So mockbean makes that work with your mock object. And that's the only difference. This is very convenient. What about verifying the mock? This is one other thing that's different between Mockito and BDD Mockito. With Mockito, you call verify with the mock, and then you put the method afterwards. This method was called action here, was called on the mock exactly once. And if it was more than once, there's a second argument to the verify method to say how many times. But if you use then with the BDD Mockito, then it never takes a second argument. You have to call should with no arguments, which means once. Or the multiplicity would go as an argument to should, and then the action. So they're trying to say then action should be called on the mock X number of times. Again, it all reads backwards, but you get used to it, you know, like most things, I suppose. On the annotations, in order to use the annotations, you have to use Mockito's JUnit runner, or that's JUnit 4, or in JUnit 5, you add the dependency, and now it's extend with the Mockito extension, .class inside there. Okay, let me skip that. And yeah, here is an example where I have an app mock at the top for the gateway now, and then I have inject mocks on the service. And if you look at the test now, you skip the whole step of creating the mock. You skip the step of injecting the mock. The rest of the steps are still there. You still set the expectations, you call the test, do your checks, and you can even do a verify at the bottom. I do like the annotations. They're nice and simple when they work, you know, but was the class you're testing designed in a modular fashion? Well, hopefully. If not, you're kind of out of luck. It's going to be hard, you know, but then it's going to be hard to do everything. So, yeah, okay, got all that. Talked about inject mocks. Yeah, this is the order they lay out. The biggest constructor first, and then setters, and then field injection. If none of them work, do it yourself, and I have a nice little example of that. So here, this is the same thing using the BDD approach. So given gateway.getResponse will return my mock Astro response, then do the test, and then verify it with a should at the bottom. Same exact test, just different API. Okay, now what about that multiplicity I was talking about? How do you do that? Well, now when Mockito creates a mock for you, it's actually smarter than just instantiating a class. When you instantiate the class, then references that are object references are just null, and lists are also null. Everything is nulls or zeros or what have you. When Mockito instantiates a class as a mock, or stub, however you want to say it, lists are an empty list, for example. You know, they do 0 for numbers and false for booleans, but they put in empty collections for the actual collections, and so on. So it's a little bit better. Yeah, we talked about the configuration, so that's all set. Oh, you could chain the then returns. When I call this method, then return this the first time, then return this the second time, and you can keep going. Then return, then return. In fact, if you just do it a couple times, whatever the last one is, that's what will be returned over and over again if you keep calling the method. So you can switch what's being called each time, if you like. Now, a nice thing that you use a lot. This thing is called argument matchers. And speaking of bad uses of inheritance, the Mockito class extends the argument matchers class, which is weird. I just have no idea why they did that. I guess so you could do a static import once and you get everything, okay? But it's a weird idea. There's no is a kind of relationship in there. Okay, stop complaining. Now, what they do in the argument matchers class is instead of having to say when list.get of 0 is called, then return 42, you could say when any int is in the argument. And they have any's for all the primitive types. Any int, any long, any Boolean. They also have any string, any, which means anything. And then the one that I always enjoy, any instance of a particular class. When any instance of this class is an argument, then do the following. Like at the bottom here, it says, when I call a get on the list with any integer, give me back 42, for example. The answer to life, the universe, and everything, you know. Okay, anyway. So there's an example of that. You can also do it on the verify side. Verify that the mock list get method with any int was called 3 times. See how you kind of have to go in weird order to understand the statement. But it's Mockito. There are alternatives to Mockito, but Mockito's got by far the biggest market share. So it's built into Spring, so kind of hard not to use it. We have all those any methods, any string. We have is null or not null. We have string with contains or matches, and all these others. So there's a whole bunch of methods in there. There's also a method called equal, EQ. And that feels really weird. It's like, why do they have an equal method? I already know what the data is. I'll just plug in the data. Like what I mean is say I'm calling a method, like you see here, that takes 3 arguments, any integer, any string, and this string. I know exactly what the last argument's going to be. If you try to write that, it fails. Because the rule is, if one of the arguments is an argument matcher, they all have to be argument matchers. And that's why you have the equal method at the bottom, see? So that you could turn that constant into an argument matcher. Now, it used to be a really obscure error that took a while to track down. Now the error message is pretty clear. So it'll tell you if you do it wrong. But boy, that's, again, one of those that you just wouldn't notice until they tell you. You can also do what's called custom argument matchers. Now, the funny thing about custom matchers is, in the beginning, there is an interface called argument matchers, singular. All those methods I was showing was in argument matchers, plural. They were all static methods in argument matchers. The argument matchers, singular interface has a single method. And it's an interface with a single method. All the documentation say you implement it with an anonymous inner class or whatever, and then along came Java 8 and said, oh, interfaces with a single abstract method? That's a functional interface. You could implement it with a lambda. In other words, they got lucky. They made a functional interface by accident. And that means what we could write down here at the bottom is saying, well, if we want to verify that on the mock, the add-all method was called with an argument that is a list of size 2, you don't have to write the anonymous inner class to do that. You just take the argument, the list, and return a Boolean, because that's what the single abstract method does. It takes the generic type that you're mocking and returns true or false. And that's all you have to do it. So the arg that part with the custom matchers is also remarkably easy to use now. But there's another potential trap that I want to call out for you here. If you try using arg that with primitives, you can potentially get a very weird error. And I wrote it in here because I was like, I just still can't believe that's the error. Note that arg that on argument matcher of type T will not work with primitive matchers due to null pointer exception, auto unboxing caveat. And I don't know about you, but I checked out nearly at the beginning of that. I'm like, what? And I asked them about it, and they still can't explain to me what the problem is. But the fix is trivial. If you see an error like that, replace arg that with the primitive, int that, long that, double that, error goes away. Those are for the primitives. So if you happen to be dealing with primitives, you can try arg that because that's what you think of first. But then if you get an error and it says something about auto unboxing, just go to the primitive ones and then you're fine. I mean, subtle little silliness. Now, what about the multiplicity ones? When you use verify, then there's no second argument to verify. That would mean the verification is 1. But there's a times method where you could put in an actual multiplicity here. I could pick a number. But there's times with an int, there's never, there's at least once, at least some number, at most some number. one of those perfectly fine. You could use those anytime you want. Helps you set the multiplicity. I did it on the verify, but you could also do it on the argument matcher. I mean, on the setting expectations part, however you did that too. There's another quirk to Mockito. I mean, we don't have a whole lot of time, so I'm trying to jump right to the quirky parts so you're aware of it. If you try to mock a method that returns void, they won't let you chain the then to it. If you try to say, when I call this, print output method on my mock, then do something, it goes, no. That method returned void, you can't do it. For reasons I, again, still don't really understand. It has to do with the way they did it under the hood. Again, there's a simple solution. You reverse it. You say do return or do throw or do answer for that, whatever we do here, when I call that method on this object. So it's just writing it backwards. Although honestly, that reads a little better than the original way to my eye. And honestly, you could use that approach for everything, but nobody does. They only seem to do that on methods that return void. But you have to be aware of it, because you'll get that error at runtime. They'll say, no, you're mocking a method that returns void. You can't chain a then to it or anything like that. Now, I said it's not just verifying that the methods were called or even called the right number of times. This is something about calling them in the right order. The way they do that is that there's a class called in order. And there's a method, I put in a new here, but in fact there's a method called in order that takes as an argument a vararg list of mocks. So you can actually say, first this method was called, or down here, method 1 was called on mock 1, and then method 2 was called on mock 2. So you could mix them if you want, although I don't have too many use cases for it, but you can do that too if you like. So it's all very manual and explicit. It doesn't scale real well. You kind of have to want to do that one. All right, but the others are pretty mechanical, but that works too. Spy we talked about. I just want to identify that in addition to having a spy method, there's also an @spy annotation, which will do the same thing. And an argument captor. Now, again, this is an edge case. You probably won't need it. If you are mocking a method, you might say for any int or for any string, let's say, here's what I want you to return. But then you don't necessarily know what string was called. When your class under test called that method on the dependency, what string did it use? Well, you can use an argument captor to capture the argument that was used in the stubbed out call and then report on it. Now, most of the time, you already know what that argument was. I mean, you probably supplied it. You may even have hard-coded it in. But every once in a while, like I may say, I'm putting in these 3 components, first name, last name, date of birth, and it's creating a person inside and then calling a method using that person, but I mocked like the repository or something, So I want to see, was the person right? You could capture it. That's what an argument captor is for, just to make sure that they put together the person object correctly before they called it. Now, again, just to finish up on the edge cases, they used to say we won't mock final types. Now they do. And again, if you're a Mockito 5, you don't have to do anything different. Just call them. Just say when I call whatever. Same thing. You can mock final methods on final types. See, this is really weird when you think about it. How did Mockito work in the beginning? Well, if you gave it an interface, it implemented the interface. If you gave it a class, it extended the class and overrode all the methods to do what you want. But how do you extend a final class, right? You can't. So they have to do all kinds of games under the hood to make a mock of a class that's marked final. But as a user, you don't have to worry about any of that. You used to have to add in the inline mock maker, which was this weird way at the bottom. Now you just use Mockito 5 and it works automatically. Okay? Just use the inline mock maker there. Now, back to that Astro Gateway. I said I was going to do an integration test on that because the dependencies were the networking library and the JSON parser. Well, we didn't write those. And the problem with mocking things you didn't write or that you don't own is there's two problems. One is, say I mocked the networking library, and then the networking library changes. My test still passes because I'm providing a fake, and I don't even know that it's not working anymore in the integration test. That's setting us up for a problem. Also, when you mock a single class in the networking library, like let's say I mock an HTTP client, oh, then I'm going to need to mock an HTTP request and probably mock an HTTP response. And oh, wait a minute, there's builders and subscribers and publishers. And in other words, it tends to explode. You wind up mocking half the library. And what are you doing? You know? So again, the lesson, and this is a link actually, goes back to that wiki page on writing tests. It says, do not mock types you don't own. Integration tests are fine for that. You're only going to lead yourself into trouble otherwise. So I don't mind creating mocks of my gateway for my service when I'm testing the service, but I'm not mocking a networking library. I'm not mocking a JSON parser. I will trust that they're doing what they're doing. And if it turns out they're not, well, okay, I'll find that out another way. I mean, I'm not going to do it by mock objects. That's the idea. Some limitations, many of which were overcome. You couldn't mock static methods until 3.4, but now you can. You couldn't mock constructors until 3.5, and now you can. You still cannot mock equals and hash code. They've dug in their heels. They said, look, that's wrong. You shouldn't be mocking equals and hash code. They always say, why are you doing that? Well, I want to test equals and hash code. That's different. Now you're testing the class under test. You can test equals and hash code. Remember, this is equals and hash code on a mock. Why would you want to do that? You know, just use the real equals and hash code. At any rate, you cannot mock private methods because as far as the class you're testing is concerned, the private methods don't exist, right? It doesn't see the private methods in the dependencies. Now, if you really, really, really want to do it, there are tools like PowerMock and others that are out there, but this is a philosophical thing where they've said, yeah, we're not doing that. They don't agree with that. Okay, let me summarize. The stubs, again, provide known outputs for known inputs. That's what a stub is. A mock is a stub that you verify, where you check the protocol. You check the interactions, the number of times the methods were called with the right arguments in the proper order and everything. No matter what you do, you create the mocks and or stubs, you set the expectations on them, if any, you inject the mocks into the class you're testing, write the test that you cared about, and then optionally verify that everything's working as expected, and then you'll be fine. And that's, I have tons of examples in that repository. If you're interested, feel free to keep in touch. If you have any problems with it, just let me know. Thank you very much for coming.